The second law of thermodynamics states that the entropy of the universe always increases with time. That sounds like an epically concise way to describe the nature of our universe, but you might be a little confused. What exactly is entropy? Entropy, in its most fundamental sense, simply describes the fact that energy tends to be more spread out, because the state of being spread out is more likely. Let me explain this with a simple example. Imagine two chambers with 5 molecules of gas. What is the likelihood that all 5 molecules are in chamber 1? Well, if we do the math, we'll see that there is only 1 out of 6 outcomes where this happens. We call each of these outcomes a microstate. Compare this to the probability of having some molecules on one side and some on the other. That's 4 out of 6, a much greater probability. It's more likely for the gas molecules to be spread out, and that's how we observe them. Energy, heat, and other physical processes work the exact same way. Often we deal with situations where there are a lot more than just 5 molecules or 5 quantities of energy, which significantly increases the probability of having a more spread out state, or a more disordered state. It's much more likely for a cup to fall off a table and break into many pieces than to put itself back together as it hits the floor. There are simply more ways, more microstates, where the cup fragments are broken and spread out, and only one outcome where they fit back together perfectly. There is no mysterious force driving this to happen, just probability. We can quantify this probability using entropy. Entropy, or the degree to which something is spread out or disordered, always increases because that's what happens in the most probable outcome. Why is this useful? Well, entropy explains why spontaneous reactions happen, or reactions where there's no outside interference. When iron is left out in the open, it rusts. When the temperature gets hotter than 0 degrees Celsius, ice melts, all on its own. Chemists have come up with an equation to calculate whether a reaction is spontaneous or not. Delta G equals delta H minus T delta S. This might sound like alphabet soup, but the gist is that delta H, delta S, and T account for the state of each material in the reaction and the environment around it. When delta G, called Gibbs free energy, is negative, the reaction leads to an increase in entropy and is spontaneous. When delta G is positive, the reaction does not increase entropy and will not happen without a change in the environment or a change in the reactants themselves. Understanding entropy and spontaneity helps chemists analyze reactions, find catalysts, and develop entirely new reactions. Entropy determines every physical process we experience, which is why it's so important that we understand it. Thank you for watching.